Iamide, Daneo, Neopatsing, Jaden, cool beans. Okay, so let's get cracking. The first, so this is, as you can see, I'm trying to give you as much practice with questions that have come up recently. So we're sort of focusing on November 2020 and November 2019 and November 2018. Matrix, if you make a concerted effort to learn your formulae, it will save you time, because then at least you don't have to keep going to the back of the paper, looking up what the formula is, and then going to the front. I mean, if you can imagine that you need to do that for every question that you answer, it ends up being quite a lot of time that gets spent, okay? So if you can learn formulae, it's really, really going to help you. But anyway, we've all got a lot going on. If you can, great. And if you can't, that's fine. As far as the first question is concerned, all right, we want to work out the values of X and Y. Anybody got any ideas as to what the starting point of this is going to be? Anyone want to share an idea? Because this would be
to find the difference. So like,
okay.
For example, say X minus, okay, wait, no. Like
you were right. So
get from, would it be X minus 7? The difference between 7 and X.
It would be, but unfortunately, if you do that in this particular question, it's not going to help you. But you're quite right.
Okay.
You're quite right. So X minus 7 is the same as Y minus X is the same as negative 11 minus Y. Quite right. 100%. Isn't that funny? Maths does that to us so often where, you know, whatever we say is correct, but it actually doesn't help us to be able to solve the problem. So yes, Luyanda, you said T2 minus T1. Neopatsing, you said A is equal to 7. Quite right. Iamida, you said find D. Okay, so how can any arithmetic sequence be written? So term number 1 of any arithmetic sequence is going to be A, right? Let me just get my pen working here. Okay, so term 1 is always going to be A. So term 2 is going to be, pardon me, what we started with, plus 1 difference. Do you remember this? Unfortunately, Neopatsing, even though that's true, you can't solve for 2 unknowns in one equation. So you're right, you're 100% right, but it's not going to help you here. Okay, do you remember this? Do you remember T2 can be A plus D? And term 3 can be written as A plus 2 differences. Do you remember your teachers teaching you that? Okay, so if we apply, cool, Iamida, you say yes. I hope the rest of you remember your teachers teaching you that as well. Okay, so now using A's and D's live, how would I write negative 11? How could I write negative 11? Any idea? If live doesn't know, not a problem. Is there anybody else who's got an idea as to how I could write negative 11? It's the 4th term in the pattern. So with A's and D's, how would I write that?
Plus 3. Oh.
There we go. Okay. Good, well done. Okay, so term 4, quite right. Term 4 is going to be A plus 3 differences. Good, Matrix. Excellent. We can see that term 4 is negative 11. We already know that A is 7, don't we, Kanya? Plus 3D. Very good. Okay, so then what is D going to be equal to? Any ideas? Good, excellent. I agree. I agree. That's what I would get as well, because we end up with negative 18 over here. Good, Karen. Good job. Okay, so D would be equal to negative 6. Have we answered the question, though? We haven't, have we? Okay, so now that we know what the difference is, now we can go ahead and answer the question. What does X have to be, Matrix? Remember, it's term 2, so it's A plus 1 difference. Is everybody happy with that? I'm just going to move this over. Yes, I agree. A C pair, you said 1. Kanya, you said 1. Good stuff. Does everybody know where the 1 comes from? Okay, so 7 plus negative 6. Excellent. Swahili, 100%. Isaiah, quite right. Okay, so now, Matrix, please can you work out what Y is? All right, so you guys do that. And Benedict, I'm going to explain that again. Benedict, are you okay with minus 11 equals 7 plus 3D and that D was equal to negative 6? Does that make sense to you? Okay, brilliant. So now term 2 is X, Benedict. So term 2 is X. And with A's and D's, it's written as A plus 1 difference. So that means that we've got 7 plus negative 6. And that's where Kanya and everybody else was getting the 1 from. Okay, and Nala and everybody's getting negative 5 for Y. So term 3 is Y. That is A plus 2 differences. So that gives us 7 plus 2 times negative 6. Okay, so that's 7 minus 12, and that's where you guys are getting your negative 5 from. Okay, so good stuff. Well done, perfect. 4 out of 4 for that question. Is it okay if I rub this off? I have got the answers here for us as well. But I just want to just clear that up. Okay, so again, I think it's really important, Matrix, that we always know where our marks are allocated. So in the case of this particular question, this is what they did. Okay, so if you have a look on your screen now, okay, there was a mark for that very important line, 7 plus 3D equals negative 11, a mark for working out that D was minus 6, and a mark for X and a mark for Y. Okay, everybody happy with that? Okay, on to, and I trust if you're not, that you will interrupt me and stop me. Okay, so now, this is strictly grade 11 work, but it's always tested in Matric, and it's generally the first question in sequences and series. So that's why I decided let's go ahead and let's talk about quadratic number patterns tonight. Okay, so these are supposed to be routine, easy questions for everybody. Do you know how to work out the values of A, B, and C? Yes, Iomede says yes. Deneo says yes. Okay, all right. Is this, okay, so Matrix, is this something that you want to practice, or would you prefer to go on to something that was a little bit more difficult? Okay, so something that's a little bit more difficult. All right, so no problem, absolutely. I don't want to waste I don't want to waste your time. Okay, so a C pair, what you can do in the meantime is work out the values of A, B, and C, because we actually need that to do the next questions, all right? So what you will find, Matrix, is that a question will build from the easy questions at the beginning to a slightly more difficult question at the end. So we're heading towards question 2.2.4, which should certainly stretch our imagination, all right? So we would work out in 2.2.1, we would work out the values of A, B, and C, which we can go and have a look at now. Then when it asks us to calculate the 50th term in the pattern, what would we do? How would we work out the 50th term in the pattern? So someone can pop it into the chat for me. Exactly. So we would substitute the 50 in place of the n. Exactly. All right. So that's easy enough. 1 mark for subbing in, 1 mark for the answer. Okay. So now let's look at this question. We wanted a more difficult one. Show that the sum of the first n differences of this pattern can be given by Sn equals 6n squared plus 3n. Okay, what are we going to do now, Matrix? Are we still working with the quadratic pattern? Another question is, when they talk about the first differences, what do they mean? Is this the right kind of difficult?
Yes, ma'am.
Okay.
Do they talk about like the first row, like when you're getting the differences?
Exactly. So they're talking about the first row, all right? So the first row of any quadratic pattern is going to be arithmetic, okay? So that first row that they are talking about is going to be this row of numbers over here, all right? So 9, 21, 33, etc., right? What I'd like you to do quickly, Matrix, is I want you to work out what the nth term of that pattern is. Remember, this is a linear pattern, okay? So it takes the form Tn equals a plus n minus 1d. So work out what the nth term is. Actually, just reading this question again, we don't need to know what the nth term is, but we do need to know what A and D are. Okay, so any idea of what we're going to do with this? 12n minus 3, that's right. That is the pattern. But now, Ayush, what they want us to do is they want us to calculate the sum of the first n differences. So in other words, in this question here, we know that the value of A is what? Was it 9? 9, quite right. Excellent. Okay.
Use that formula.
And what's the difference?
12.
It's 12. Okay. So if they want us to calculate the sum of the first differences, that is an arithmetic sum. So we have to use the formula Sn equals n over 2 times 9, so 2a minus plus n minus 1, and then our differences. Okay, so that's what we're doing, right? So they want us to work out the sum of the first n first differences of this pattern. Is everybody happy with that? You would then simplify this, and that's how you would end up with the 6n squared plus 3n. Okay, so the first thing that you would do, matrix, is inside the brackets, you've got 18 plus 12n minus 12. So that leaves us with n over 2. 18 minus 12 is 6. So this is 12n plus 6. Okay, and now we're going to multiply n over 2 with 12n. That's where the 6n squared comes from. I'm just going to move this down. So now removing the brackets, we're going to multiply n over 2 with 12n. That is going to leave us with 6n squared. 12 divided by 2 is 6. And then when we multiply n over 2 with 6, okay, 6 divided by 2 is 3, and that's where we would get 3n. Okay, so our marks here, we can't have a mark on the last line. Our mark is going to be for subbing in. And then I would think we would need to know what our A and our D are. Let's go and have a look at what they said the marks were on for 2.3. Okay, so there you go. All right. So the marks were for A and D, working out that A is 9 and D is 12, subbing into the formula. And then you also had to get the n over 2, and in brackets, 12n plus 6. Is everybody okay with that question? Thumbs up. All right, so now I hope your brains are sufficiently warmed up, because now we are going on to a more challenging question. All right, 224. So have a look at that. I'm just going to rub this writing out. Okay, I'm glad. So how many consecutive first differences were added to the first term of the quadratic number pattern to obtain a term in the quadratic number pattern that has a value of 21,060? So this is a problem-solving kind of question. And with these kind of questions, it's important for us, I suppose, like with all maths questions, we want to try and crack the first line. Any ideas, grade 12s? What would we do here? Where do you think we would start?
They gave us the equation of, okay, we got the equation as 6n squared plus 3n. So do we say 21,060 equals to 6n squared plus 3n? Then we do quadratics.
So are you saying you want to make 6n squared plus 3n equal to 21,060?
Yes, ma'am.
Yes, quite right. 100%. There's another way that we can do this as well, but absolutely. 100%. Okay, so go ahead. I'm really pleased. That was actually not as difficult as we thought. Okay, go ahead and go and sub it in, and then see if you can work out the value of n. Okay, well done. Oopsie. Okay, so let's see what you get, Matrix.
So
Yes.
do we round off if we get I got 58.99?
I know that the answer, 58.99, yeah, you were supposed to get 59 as an answer.
Yes, ma'am. So do we, okay.
Did the rest of you get that as well? $59, that's right. Good, well done, Neopit Singh. Do you want me to show you the answer, grade 12s? I'll show you where the marks were. We ready to move on? Yes, please. Okay, all right, no problem. Okay, so over here. All right, now, there was something that we forgot. All right, so when we wanted to use that SN, all right, what we needed to do, remember, if they were asking us how many first differences would we need to add to the first term to get a value of 21063. So our first term, if you recall, Matrix, was -3, right? To that, we are adding SN, and we are obtaining an answer of 21060. So what we should have done is we should have said -3 and then subbed in our 6n squared plus 3n and made it equal to 21060. Okay, then what we would have done is brought everything over to the left-hand side, made it equal to 0, standard form into this quadratic formula, and then we would have worked out that n was 59. It cannot be negative because a term number cannot be negative. Is everybody okay with that?
Yes, ma'am.
Okay, thanks, Omide. Thanks, Daneo. Okie dokie. Unfortunately, no, but saying n equals 60 is not an acceptable answer in this case. It has to be 59. Okay, you can't have a negative answer, and you can't accept a fraction. Okay, so it would have been 59. Okay, so next question. We want to prove that the sum to infinity for 4 times 3 to the power of 2 minus k, where k is equal to 1, is a convergent geometric series. And we want to show all our calculations. All right. What are we going to do here, Matrix? Where do we start? When they give us sigma notation, what is the first thing that we need to do?
We get the R first. So,
Okay, so you need A and you need R. So you need to generate the pattern. And the pattern is generated by substitution. So what you need to do is the number at the, well, this is sum to infinity, but when we have sigma notation, right, this is important for you guys. When we have sigma notation, there is a value at the top and there is another value at the bottom. Okay, so when we are subbing into our rule, which is always given next to our sigma notation in brackets, the first number that we sub in is the number at the bottom. The last number that we sub in is the number at the top. Also really important, if we want to know how many terms there are in a particular series, we have to say that the number of terms in the pattern is equal to the number at the top minus the number at the bottom plus 1. So I'm sure you would have heard your teachers telling you that before as well. Okay, in this case, this is a sum to infinity, but you know, so there's not going to be the number of term ends are infinite. But if you were working with just a normal geometric series, this is what you would do. Okay, so in question 3.1, we want to start off by subbing in k is equal to 1. So when we sub in k is equal to 1, what is a equal to? Anyone got an answer? Okay, so Anya says 12, Kanya says 12. Perfect. Okay, so 12 is the first term. Okay, so now if you subbed in k as 1, now sub in k as 2. What's our second term? Indeed, 4. Okay, now, so always try and do 3, okay? So what do we get when we sub in? 3, because we started at 1, so we subbed in 1, we got 12, we subbed in 2, we got 4. When we sub in 3, what would we end up with? Indeed, okay? So this means, matrix, that A is equal to 12, right? If we want to prove that a series is convergent and that it's geometric, what do we need to show?
Limit between 1 and -1.
Exactly. So we need to show that R is greater than -1 but smaller than 1. Okay, so now your job is to work out the value of R. So either, quite right, Neopet saying, so 4/3 needs to be divided by 4, or you could say 4 divided by 12. Exactly, 1/3. Okay, so because 1/3 is greater than -1 and smaller than 1, therefore the series must be a converging geometric series. Therefore, converging geometric series. Okay, everybody happy with that?
Yes.
Okay, I'm going to rub this off. Have a look at the next question in the meantime. All right, now they ask us if the sum to infinity, where k equals p for 4 times 3 to the 2 minus k equals 2/9, determine the value of p. All right, so this is out of 5. So what do you think we should do first of all, matrix? And what do you think the 2/9 represents? Is the 2/9 an SN or is it a TN? And how do we know the difference? It's an SN, quite right. Okay. Beautiful. Okay, so it's an SN. It's the sum of the series by the equal. Indeed it is. Okay, so 2/9 is the sum of this infinite series. What's the first thing that you're going to sub in? What's going to be the first thing that we sub into our rule? Well, we would get A from subbing the first thing, but what is the first thing that we actually need to sub in? So underneath at the bottom, remember that's always what you sub in first, okay? So K equals P. So what they want you to do is they want you to sub P in first. Does that make sense, Matrix? It doesn't, okay? All right, so, okay, no problem. So when we have, so going back to what we were talking about before, all right? Let's just clear some space over here. When we have sigma notation, all right, if we're talking about sum to infinity, we would have an infinity symbol on top. And the first number that we would substitute into our rule would be the number underneath. So we could work in terms of K, we could work in terms of P, they could literally give you anything. So let's say here they say K is equal to 3. If I have a rule here, so 2 times 3 to the K, then I'm going to create the first term in this series by subbing in 3, right? So term A would be equal to 2 times 3 to the power of 3. So that would leave me with 54. But we don't have that. We have sum to infinity, right? So in this case, they tell us that K is equal to P. So just like this 3 was the first thing that I subbed in over here, the first thing that I need to do is I need to sub in P. So my rule is 4 times 3 to the 2 minus K. So what I'm going to do, Matrix, is I'm going to replace this K over here with P. So that means A, the first term in the pattern, is going to be 4 times 3 to the 2 minus P. That's going to be the first term. Does that make sense now?
Yes, ma'am.
Okay. So every time we sub in one more. So if I wanted to work out the next term in this pattern, so the one on the left, I would sub in K is equal to 4. 4 is 3 plus 1. So now when I sub in here in the red on the right, I need to sub in one more than P. So my second term of my series is going to be 4 times 3 to the 2 minus P plus 1. Does that make sense? My third term is going to be 4 times 3 to the 2 minus P plus 2. Right? And these continually add up and add up and add up. Why is it not 2P? Okay, because that's 2 times P. This is 2 more than P. Okay, so 2 more than P is P plus 2. Twice P is 2P. Okay, all right. And we know that all of this adds up to 2/9, right? So when we work with sum to infinity, our sum to infinity formula is A over 1 minus R. P, you got 4/27. Can't remember if that's the answer that I got, Sepo, but we can go and have a look at it now, okay? Let's just simplify these terms a little bit, okay? So 4 times 3 to the 2 minus p, there's nothing we can do. So that's 4 times 3 to the 2 minus p. This becomes 4 times 3, 2 plus 1 is 3 minus p. This becomes 4 times 3 to the 4 minus p, plus whatever it is, adds up to 2 over 9, right? What we notice is that this rule over here, matrix, is identical to that one over there. We already know what the value of r is. Remember, in 3.1, we worked out that r was equal to 1 over 3. So when we sub into sum to infinity, we need r and we need a. We've got a. There's a over there. So subbing in to your sum to infinity formula. Sum to infinity is 2 over 9. A is 4 times 3 to the 2 minus p, all over 1 minus r, which was 1 over 3. Does that make sense to everybody? Okay, good. All right. So Karen, Ayamide, you carry on going here and let's see what you got. So Tsepo says he got 4 over 27. I don't remember getting that when I did this, but I could be wrong, Tsepo. Okay, are there any questions, Matrix? Is there anybody that's not sure of what I've done here? P equals 5. Yes, that's what I remember getting Newton. Good, well done. Okay, what about everybody else? Did you manage to get P is equal to 5? Yes, Benedict. Okay, Tsepo, did you see where you made your mistake? You struggle with these types of questions. That's okay, Ayush. No. Okay, Nala, you managed. Okay, so let's try this, okay? Obviously, it's a little bit difficult when we are online, but let's do the very best that we can, okay? What I suggest is this. If you managed with this question and you are feeling confident, why don't you go on and start on this question over here, number 2.2. We'll leave this one out of it because we're okay with quadratic sequences, but try this question. In particular, I mean, it is nice for you to answer K, that's fine. But in particular, I want you to answer this question over here, 2.2.2. Okay, so if you were confident with the red and you know exactly what you're doing, you can move on in the meantime, work out the value of K, and then get started on question 2.2.2. Okay, so anybody who was struggling, Swelile, Ayush, anybody else who wasn't sure what to do over here, you can now follow me. Are you happy with how we got to this point though? So Swelile, does it make sense where I've written 2 over 9 equals 4 times 3 to the 2 minus b over 1 minus a third? Does that make sense to you?
Yes, it does.
Okay, beautiful. All right. So now what you want to do is a whole lot of manipulating, right? We want to isolate the base 3 times 2 to the minus, 3 times 2 to the minus p. Okay, we want that on its own. So what we want to do is we want to cross multiply. Okay, that will be our first step. So when we cross multiply, what are we going to end up with? So 1 minus a third is 2/3. So 2 times 2 over 3 leaves us with what on the left-hand side? Do you get 4 over 3?
Yes, ma'am.
Okay. Then on the right-hand side, 9 times 4 is going to leave us with 36 times, whoa, what kind of 3 is that? Sorry, matrix. Is going to leave us with 3 to the 2 minus p. Okay, so now what do we need to divide both sides by?
36.
We need to divide both sides by 36, quite right. Okay, so now what we end up with is 1 over, do you guys get 1 over 27?
Yes.
Yes, ma'am.
Yes, ma'am.
All right, excellent. And now what am I going to do with 1 over 27? How am I going to rewrite that?
What is it?
Prime, maybe, ma'am.
So you're right, I need to write it with base 3.
3 to the power of 3.
3 to the power of -3 matrix. Okay, why is it -3?
1 over.
Exactly, exactly. Okay, so now that is equal to the power of, 3 to the power of 2 minus p. Okay, so when you are solving for an exponent, the whole idea is to equate the bases, make the bases the same. So here we've got base 3 and here we've got base 3. Once we have equated the bases, we can equate the exponents. So if -3 is equal to 2 minus p, and we take that over to the left, we'd have positive p, take that over to the right, it would be 2 plus 3, and that's why p is equal to 5. Does that make a little bit more sense?
Yes, ma'am, it does. Thank you.
Okay, it's a pleasure. Greatest pleasure. All right, so just looking very quickly, then we can get started on those questions up there. I just want to show you where the marks were allocated for that one. Where did I have it? Oh, no, that's another question I want to do with you. I think it's over here. Oh, there it is. Okay, so Tsepo, now I understand where you got that 4 over 27 from. Okay, but it was supposed to be 4 times 3 to the 2 minus b equals 4 over 27. Okay, that makes sense now. Okay, so maybe you just didn't carry on. All right, so matrix in this question, there would have been the expression for a, so that's why we just need to simplify it a little bit. Okay, then subbing of a and r and sum to infinity. That is an accuracy mark on that substitution. If you don't sub into sum to infinity, you won't get that mark. Okay, so it's very important in matric that you have to sub into the correct formula. Okay, simplifying, so we ended up with 4 times 3 to the 2 minus b equals 4 over 27. Equating the bases so we can equate the exponents, and then the last mark was for the answer. Okay, all right, so let's fly back and go and have a look at what the others were working on. Be nice if we can do one. We don't have time.
Yeah.
Lessons go. Yes.
May I ask for the formula for the sum? Let's look at it.
Sure. Let me go and grab the formula sheet for you. So there we go. There are your formulae. Okay, so if you haven't started already, matrix, start on question 2.11. We work out the value of k. And then we can talk about the second question. Okay, has anyone got an answer for k yet? Okay, so just so that we are able to finish question 2.2.2 as well, matrix, I'm sorry I'm interrupting you. Because they told us here it's a geometric series, we've got to use a geometric sum. So we've got to use this formula over here, all right? K represents sum to n, all right? They've told us that n is 21 terms. So in other words, K, which is Sn, all right, is going to be A, the first term in the pattern is 5/8. Oh, wow, you've already done that question. Okay, Neopatsing, I'm going to answer you right now. Sorry, I'm just doing this one over here. The value of R, I got 1/2 to the power of 21 minus 1. And all of that needs to be over R minus 1, and R is equal to 1/2. Did the rest of you get that? Yes. All right, lovely. Okay, so what did you get as a value for K? Anybody tell me what they got for K, matrix? 1,25. Okay, all right, perfect, well done. Okay, so there it is. Okay, so a mark for R being 1/2, subbing into the correct formula like we had written over there. Oh, they've used it the other way around, doesn't matter. And then we would end up with 1,25 as an answer. Okay, so good stuff, well done. All right, now Neopatsing, you were flying with that other question. All right, so no, the answer is supposed to be 10. But let's go and have a look at this. Do you know what to do with this question, matrix? Do you need me to get you started, or are you confident? So I'm just writing this down. A is equal to 5/8. And for this particular question, R was equal to 1. So they want us to calculate the largest value of n for which Tn, your R was a half. But saying that's quite right. Yeah, sorry, I left the divided by 2 over. Sorry. I also had a half. Sorry, I'm obviously quite right. I also got a half as my R. Okay, so your Tn would be AR to the n minus 1. Okay, so this is going to be 5 over 8 multiplied by R is a half, okay, to the power of n minus 1 greater than 5 over 8192. Okay, so what's the first thing that we need to do, Matrix?
Do we divide by 5 over 8?
We're going to divide by 5 over 8 on both sides. And what are we going to end up with? I agree, Sake. That's what I got as well. Yes, Neopitseng, I agree. So 1 over 2 to the n minus 1 has to be greater than 1 over 1024. Now what? Okay, so again, what I have to do in this case, exactly, right? Indeed. All right, so 1024, we now have to write as 1 over 2 to the power of something. Okay, so you can do that. You can't go 1 over 1024, but if you put 1024 in your calculator and press equals and shift fact, it'll tell you what it's 2 to the power of whatever. As it turns out, 1024, as Neopitseng said, is 2 to the power of 10. Okay, so now what we've got is 1 over 2 to the n minus 1 is greater than 1 over 2. Yes. To the negative 10. Yes, negative 10. Yes, positive. Oh, that's right. I'm sorry. I don't know what's wrong with my brain today. Of course, it has to be positive 10. Quite right. Okay, like so. So now n minus 1 has to be greater than 10. So in that case, n has to be greater than, take the 1 over, 11. Right, so the largest the largest value for n, for which this is going to happen, if n has to be greater than 11, the largest integer value of n must be 10. Yeah, that is right. Because, look here, it has to be, oh no, hang on. Neopitseng, what am I doing? It's been a long day. What did we not do?
We didn't
16.
say the largest.
How come we ended up with 5 over 8 times 1 over 2 to the n minus 1?
Ma'am, I think when we divided, right, 5/8, I believe the
Yes.
sign should have changed. This again.
What have we done wrong here? Sorry, Matrix. But if we divide, then our sign is not going to change, is it? I mean, if we divide by a negative, then our integer value, then our sign is going to turn around. But if we don't, then it won't. Yeah, it said, where did they get the 860? Oh, because it was all over 5, wasn't it? 5/8, 5/16, 5/21 terms. Oh, I see what I've done wrong. Okay. Very quickly, let's just fix this. Well, it's not wrong, but I see what's happened. Okay. When we are working with the inequality, all right, we can't actually, that's what I've done wrong. We shouldn't have worked with a fraction. So in other words, remember we had the number 5/8. Then we had 5/16? Then we had 5/32. And they were asking us to solve for Tn is greater than 5/, and it was 8192. So in the same way, like if you've got the same thing at the top over here, the same thing at the top over here, the same thing at the top over here, the same thing at the top of there, we can actually disregard that. So in other words, our pattern is actually 8, 16, 32, and we want to work out for which value of t, or which value of n will our Tn be greater than 8192. That's where we went wrong. So here, our A value is 8. Where I went wrong, our R value is going to be equal to 2. So subbing into Tn, we would have had 8 times 2 to the n minus 1 has to be greater than 8192, like that. Okay, divide both sides by 8. So the 8192 divided by 8 leaves us with 1024. So now we've got 2 to the n minus 1 greater than 1024. Like that. And 2 to the n minus 1 is greater than. Okay. So now n minus 1 is greater than 10. Why do I still? But they said greater than, didn't they? Why is it smaller than?
Ma'am, is it because we were supposed to make the fraction like the power of -1, and then it will be -n equals -11? Because of that, that crocodile mouse changes its direction. Because of a negative.
Yeah, no, it's unfortunately it's not because of that. It's not because it was the n minus 1. So that still means that n is positive. But the question had said for which it would be greater than, didn't it? The largest value of n for which Tn is greater. Matrix, what I'm going to have to do, what I'll do tonight, I mean, we can talk about this tomorrow, because unfortunately we've gone 3 minutes over. I will have a look at this question again, and I will see maybe there's something that I've misinterpreted here, but can't understand why we're not getting the same answer as it says in the memo. Anyway, maybe the memo is wrong. I don't know. But yeah, let me have a look at it. And this is where we'll start tomorrow night. Okay. I'm sorry about that, Matrix. Are you all right with that if we start there tomorrow night?
Yes, ma'am.
Okay. All right. Thank you for being understanding. I'm not 100% sure why that happened, but I'm sure we'll be able to fix it tomorrow evening. Thank you very much. Okay, well done, everybody. We've got through a lot tonight. So great work. Well done to all of you. You've worked really hard. Thank you. You too. Have a great day.
Is it possible that we could just keep you for another hour? No, I'm totally kidding.
Oh, shame.
But thanks so much, Lee. I think these questions are so tough. I didn't know that, sequences and series are so tough, but thank you so much. This is
it is a tough. Yeah, no, it is. It is a very tough section. There's a lot of tricky questions that can be asked. It lends itself very nicely to problem solving. And in fact, what I wanted to do, it's a pleasure. It's a pleasure. I'm sorry about this last question not working out the way we want, but I actually really wanted us to do another problem solving question. I wanted us to look at, I know the students are basically going now, but I wanted us to look at something like that. But anyway.
I mean, if you could send it to me, ma'am, we can see if we can't send it to them on the chat via the app, and they can try it.
All right. Okay. All right.
Okay,
that'll be really nice. Yeah. So I'd like them. I was hoping I was going to be able to get as far as this one. We almost got there, but not quite. Okay. Thank you so much for your help, Coco.
Sure, no problem.
Yes.
I'm sorry, but I couldn't help but notice the answer still says that this is the answer I got, and it's the same as the answer sheet, and it says 11 is still greater than n.
So yes, that's you're right. That's 11 is greater. See, that would be the other way around. If you're saying that 11 is greater than n, what you're really saying is that n is smaller than 11. All right, which is correct.
Oh.
Okay, according to that answer. So if n is smaller than 11, then n would have to be equal to 10. Please, can you tell me, because, sorry, when something like this goes wrong, I always need to go away and think about it quietly and then sort of figure out what I've done. What have I done wrong here? Why? Because they said greater than. So in other words, what's wrong here is our sign is the wrong way around, right?
Yes.
That's essentially the problem.
That is, yes. It just confuses me a little bit.
I don't understand why the sign is the other way around, because they had said for which Tn was greater than 5/8192. Then in the memo's answer, what they've done is they have changed this from being greater than to being smaller than. So your sign swaps around when you divide by a negative.
Yes, but I don't see where we divided with negative.
I don't see where we divided by a negative either. That's why I can't understand why it's that way.
Yeah, but unfortunately we are out of time.
Sorry, I'm sorry.
Guys.
I will go.
I would let you have the conversation, but we really do need to go.
Sorry, Matrix.
I'm sorry. I'm sorry for asking the question. Sorry.
No. Don't be sorry.
She's here tomorrow again.
Don't be sorry.
Okay.
Okay. All right, thanks, guys. I'm just gonna share my screen quickly. I just need to share with you guys your homework so you guys can actually see what you need to get done. Hopefully this comes out. So we are on Tuesday, which is lesson 2, sequences and series. Lucky for you guys, the next 2 days you'll be working on functions and inverses. So maybe you can squeeze a couple of sequence and series questions in there before you guys get started on functions and inverses. So fingers crossed for tomorrow. And the homework we're going to be looking at, again, we're going to exam revision, and we're going again to that same paper, but this time, instead of doing question 1, you're going to be doing question 2 and question 3. So you guys just need to go look for question 2 and 3. They are on sequences and series, and you guys can try those out. Please, guys, if you do have your answers and you'd like to share them with Teacher Lee or me, I'm on the other side of the chat. We both are actually. Just take a picture and send it to us on the chat. We're more than happy to look through it for you guys and give you feedback on that after you've tried all of these questions. Okay, again, the Maths Anxiety Workshop is happening this Friday at 6. So if you guys are, chilling at home, you can't really go anywhere with COVID. So you guys should just pop onto our Zoom call and you guys can check this out along with us. Okay, and that is all we have time for today, guys. I'm so sorry. We are going to have to go. All right, guys, you can unmute and say bye to Teacher Lee, and we will see you guys tomorrow at 6 p.m. Okay, bye-bye, everyone.
Bye, everybody.